So here we're going to look at how to solve two simultaneous equations using the substitution method. This method is quickest when one variable is by itself in one or both of the equations, and it's important to set your workout like these examples show. When you have answers that end up as fractions, you should leave them in a simplified form, either as a proper or improper fraction, because they're easier to check your answers with. Okay, in this first example, you'll see we've got two equations with y by itself. The first thing to do is to label each equation. So that's going to be equation 1, and that's equation 2. Now I'm going to set the right-hand side of both equations equal to one another. And I just say equation 1 equals equation 2. So 4x minus 3 from the first equation equals 9 minus 2x. Now we follow the rules of equations. Change the side, change the sign, so that becomes a positive 2x. I'm going to do the same with the negative 3. Change the side, change the sign. And we're left with 4x plus 6x on the left, and 9 plus 3 on the right gives us 12. Next thing I want to do is get rid of the 6 by dividing both sides by 6, and that leaves us x equal to 2. Now we're only halfway there, so now we have to substitute into one of the formula I started with. I'm going to use equation 1. I could have used 2. So y equals 4 times x, which is 2, minus 3. So you can see I've taken that x there and replaced it with what we think the answer is, 2. So y equals 8 minus 3, and y equals 5. Now before we can write this for sure, we can check using the equation that we didn't use before. I used equation 1 to get y, so I'm going to use equation 2 to check my answer. So if I take my equation 2, y equals 9 minus 2x, replace y with 5, equals 9 minus 2 times x. Now x I thought was 2, and you can see that 9 minus 2 times 2, 2 times 2 is 4, and 9 minus 4 is 5. So it checks. So there I can write my statement. Therefore, xy, we put x first and y second, is equal to 2, 5. And if we physically made the graphs of these two straight lines and put them on the same number plane, we would find they would cross over at x equals 2 and y equals 5. In other words, x equals 2 and y equals 5 satisfies both equations, and it has the physical meaning of the intersection point between the graphs of these two straight lines. In my second example, I have another two sets of linear equations. I've labelled them 1 and 2. This time you can see the second equation has y by itself, so we're going to sub the second equation into the first equation where y occurs. So we're going to pick this y value up, which is minus 3x, and put it where the y is in the first equation. To show that, we're going to use some brackets. So x plus 2 times, now this is where I pick the y value up, minus 3x, put it where the y was in the first equation, equals 15. Now following the rules of BIDMaths and equations, I've got to do this multiply first. So I have x, 2 times negative 3x is negative 6x is equal to 15, and x minus 6x is minus 5x equals 15, and I want to get the x by itself, so I divide everything by negative 5 to give me a value of x equal to negative 3. So we're only halfway there. So now I'm going to substitute this value into the first equation. It's actually quicker to use the second one, but I'm going to use the first equation just to go through the process. So in the first equation, the x is -3 plus 2y equals 15. Then I'm going to get the y by itself. I've got to get rid of this first, so I'm going to change the side and change the sign. So I end up with 2y is equal to 18. And to get y by itself, I need to divide all terms by 2. And the 2's will cancel, giving me y equals 9. Now before I state the answer, I can always check if I'm right using the equation that I did not use. So now I'm going to use that easier equation 2, and I believe that y is equal to 9, and I'm going to replace the x here with -3, so I end up with -3 times the x value of -3, and that's equal to 9, and of course that's true. Therefore my intersection point physically, and the value of x is -3, and the value of y is 9. That's the intersection point of the graphs of these two straight lines, and it's the x value and the y value that satisfy both equations simultaneously. In my third example, I've labelled the two linear equations 1 and equation 2. I'm going to substitute 2, the second equation, into the first equation where y occurs. And 3x plus 2 times y. Now because y is equal to 3 minus x, I need to put that in a bracket. 3 minus x to make sure that 2 multiplies both things is equal to 5. So you can see I've picked this up and replaced it where the y is. Following the usual rules, I'm going to have to expand this equation, so bracket I should say. So we've got 3x, and then we've got 2 times 3 is 6. I've got 2 times negative x is -2x equals 5. I want to collect these like terms. 3x minus 2x is x. And now I want to move that 6, change the side, change the sign. And so I end up with x is equal to -1. Now I'm going to substitute this into equation 2. Just easier because the y is already by itself. So y equals 3 minus, because that's the minus in the rule, x. Now x is -1. So when I have two signs together, if they're the same sign, I can replace them with a single plus. And so y is equal to 3 plus 1 is 4. Now I can check using the equation I didn't use. So I'm going to check in equation 1. And equation 1 gives me 3 times x, which I believe is -1, plus 2 times y, which I believe is 4, is equal to 5. And 3 times, I've got to do the multipliers first using BIDMAS. 3 times -1 is -3, 2 times 4 is 8, and -3 plus 8 is 5, and 5 equals 5, so we're right. So therefore, the intersection point physically of these two straight lines occurs at x is -1 and y is equal to 4. And so that means it satisfies both sets of equations when x is -1 and y is 4. Now in your textbook, you probably noticed that a lot of these answers come out to nice whole numbers, and that's pretty normal at this level, but you can sometimes get harder ones which come out to fractions. Don't be surprised if that occurs. When it comes out to fractions, the checking process is much easier to do if you leave your answers as simplified improper or proper fractions.